Now that we have our regression line, we are actually going to need to interpret the meaning of the slope and the y-intercept. Now, the slope, or sometimes called the marginal change, represents the amount that y changes when x changes by 1 unit, which if you think about previous math courses, when you learned to calculate the slope, you did change in y divided by the change in x. So that's why the slope represents how much y changes, because that's our numerator, when x changes by 1 unit. So when we interpret these, you can use this structured sentence here if you want to. You do not have to. This is not the only way to interpret it. But if you need something a little more concrete, this sometimes helps, especially when you're first starting it. So we would say that the y-axis topic increases or decreases by whatever value we got for the slope, and then we would put the unit of the y-axis for every x-axis topic in unit. So if we use our example, if we go back to what we were talking about, x represented the number of children per household, and then y represented the amount spent on groceries per week. So if we do our interpretation here, we would say, okay, the y-axis topic. Well, the y-axis topic was money spent on groceries. So we could put the amount spent on groceries Now we have to decide, was our trend line increasing or decreasing? So you want to look at the slope of it, and the slope of our trend line was positive, so that indicates it's increasing. So the amount spent on groceries increases by, now the value that we got for our slope, we need to insert next. So by 20.5. Now it says we need the unit of the y-axis. Well, since we were measuring this in dollars, we wouldn't want to put it at the end of our 20.5. We would actually want to sneak it in here at the beginning of the 20.5, because that's the standard way to write our notation for money. Okay. And then for every, now our x-axis topic. Well, our x-axis topic, well, we were talking about the number of children. So for every child, and then our topic in unit, well, our child we just measure as children, so we're not going to have a special unit. But we always want to go back and make sure that our sentence makes sense. So we would say the amount spent on groceries increases by $20.50. Let's put a 0 on there so it makes sense as a dollar amount. So it increases by $20.50 for every child in a household. Okay, we are missing one piece in there, and that was per week. So I'm going to come back here. The amount spent on groceries increases by $20.50 for every child. I'm going to put per week in here. So it increases by $20.50 per week for every child in a household. Okay, so now when I read through it, the amount spent on groceries increases by $20.50 per week for every child in a household. That is a lot more complete and has all of the pieces of my my data set and my labels. Again, this is not the only way to write this particular phrase. You could say the amount spent on groceries per week per child increases by $20.50. So there's different ways that you can word this, but you always want to make sure that you have all of the pieces in there somewhere. Like how I had first missed, it was per week that we were measuring this and had to go back and modify it. Now we're also going to need to interpret the y-intercept, and that's going to represent the amount of the y topic that would be expected to be present if there was 0 of the x topic. So if we do that for our situation, and again, remember our x and our y topics up here, we could do something like if there was, well, our x topic is number of children. So if there were 0 children in a household, we would expect, okay, the amount to be spent on groceries, because that's our y topic. And make sure we put in per week there. And we would expect that amount to be approximately $153, because that was the value that we got for our x-intercept. And again, just like with the slope, this is not the only way that you could write that phrase, but that would be what that 153 is giving us an indication, is if there was no children, we would expect the amount spent on groceries to be about $150 per week. Now, oftentimes, once we get a regression line, we're going to be asked to make predictions. And before we jump into that, though, we need to graph the regression line with the scatter plot to determine if it is a good fit. Now, if the line appears to be a good fit, then we can use the regression equation, our y-hat equation, to predict the value for y. If it's not a good fit, then we go with the general, the best predictor for any value of y is y bar, where y bar represents just the mean of the y values. Now, when we were in StatCrunch, we saw that when we do the regression, it gives us that graph with the regression line, and we were able to see already for our data set that it did appear to fit rather well. So we can go ahead and use our y-hat equation to do the prediction. So we had for our equation that y-hat equals 153 plus 20.5x. So we're going to look at 2 different categories of prediction. Our first one is going to be interpolation. And inter means within. So that means our x values that we're going to predict fall within our data set. Now, our x values for our data set, the lowest value was 0 and the highest value was 3. So we are going to pick an x value somewhere between 0 and 3 inclusively, and we're going to use that to make a prediction. Okay, I'm going to go ahead and just pick x equals 3. So if I want to know what does my regression line or my prediction line indicate would be the expected value if there were 3 children, I can take this 3 and I'm going to plug it in for my x in my regression equation. So I would have y-hat equals 153 plus 20.5 times 3. And so this is going to give me a predicted value. When I do that computation, I end up getting 214.5. So this would indicate to me that if we had 3 children in a household, we would expect the amount spent on groceries per week to be about $214.50. Now, if we look back at our data set, that doesn't have to match our data set because this is a predicted value and our data set was observed values. And from our data set, we had for 3 children, it was $210. That is okay. This is just a predicted value. Now, our next category of prediction is extrapolation. So this indicates that we are going beyond the range of our x values. Now, since x represents the number of children, I'm not going to put a negative in there because that wouldn't make any sense at all. So I'm going to pick a value that's larger than 3. So I'm going to just use x equals 5. Now, in order to use my regression equation, I'm going to do the exact same thing I did before. I'm going to take 153 plus 20.5, but now this time I'm going to insert a 5 in there for my x value as opposed to that 3. And when I do that computation, I get a predicted value of 255.5. So this would indicate that if there were 5 children in the household, we would expect the amount spent on groceries per week to be about $255.50. And again, this is just a predicted value. Now, when you're looking at interpolation and extrapolation, you have to be very careful when you get to extrapolation, because since it goes beyond the range of our data set, we don't know if maybe there's actually some other pattern once we get beyond our range. So our data set might look like it's a nice straight line, but maybe if we had more data values, we could see a nonlinear pattern. Okay, that's not always going to be the case, but extrapolation is a little bit more risky and oftentimes not as reliable because we typically don't know what happens beyond our data set. Okay, the last thing they're going to partner up with this is you're going to be asked to compute the residual. Now, our residuals, we have to have an observed value. That comes from our data set. So I'm going to do the residual for the interpolation because we have an observed value for 3. If we go back to our data set, the observed value when x was equal to 3 was $210. And then our predicted value we computed right here was $214.50. So a residual essentially is a measure of how far off were they. So we always take our observed value minus our predicted value, and in this case I end up getting negative 4.50. Okay, now the negative is just an indication that the observed was smaller than what our predicted value was. So we would say our residual for this one was negative $4.50. So observed was less than what was predicted. Now you won't do residuals for extrapolation because extrapolation, we go beyond our data set, and if we're beyond our data set, we don't have any observed values. So you would only do a residual when we're working with interpolation. Okay, so far in this video, what we did was we just looked at what a regression line was and the basic requirements that we're going to worry about. We looked at how to compute it by hand and by using StatCrunch. We interpreted the slope and the y-intercept, and then finally we used it to make predictions and compute residuals.